welcome everybody to this report back on the Socceroo cricket gear project with myself, Lillian and Darshil. And I'll just briefly introduce the project and then pass over to colleagues, and then we aim to finish by 11:30 latest. So firstly, as one always should say, thank you very much to the funders, to UKRI and the NISA programme for the funding for this feasibility study project. So next slide, please. So the background to the project is, for a while, maybe 3 or so years, we've been looking at circularity in cricket gear, because nobody else has, apart from Darshil, really, and that's why we joined up with Darshil. So effectively, most of the focus in cricket and a lot of sports has been on the higher sort of ticket items, if you like, of energy in the built environment. But it seems to be much less focus on sustainability and the gear used to play sports, in a nutshell. As mentioned before, this project is funded by UKRI through the C Hub Flexible Fund, and we're running this project from September to September 22 to 23. Next slide, please. So within the project, we have ourselves, myself, Darshil, Lillian, Darshil's colleague Beth, consultant Tom Clark, and also a former Glamorgan cricketer, Joe Cook, who has a background in his studies in sustainability, who's still looking to, I think, get back into the professional game, but is between counties at the moment. So next slide, please. And we have a number of partners in the project. Yeah, you can see the logos there. I think for time, let's move on. And I just sort of start off with a key point. In the cricket gear sector, the vast majority of gear used to play the game is produced from outsourced manufacturing to particularly India and Pakistan. And what we've seen, for example, this is an annual or biannual or so review that's done by the Heritage Crafts group, and it's highlighted really that cricket ball manufacturing in their terms is extinct in the UK. There is one organisation that's partially producing in the UK, but the cricket bat manufacturing sector, as they define, is under pressure, because of the growth in the game and other suppliers. So a lot of those skills that perhaps historically existed, 20, 30 or 40 years ago, have really moved out to other parts of the world. So really, in this sense, UK is a sort of, let's say, a consumption economy rather than a production economy. So next slide, please. And that's also a highlight. This highlights, actually, quite interestingly, the demise of craft skills in many areas as well, which is important for other sectors. So what again I want to sort of illustrate is nobody's really looked at. We found it incredibly difficult to get accurate statistics on the sort of production or use of cricket gear in the UK and globally. Very few studies, and those studies are incredibly expensive, and with some question marks over the quality as well. So what we brought in as our colleague Tom, who's a 40, 50-year management consultant, worked across many markets over the years, very forensic with his experience, and we've come up with some sort of numbers of cricket gear that's produced and some estimates over waste. And we can see there's quite substantial waste numbers associated with those sectors. You know, where do cricket pads go when they die? We have no idea. We think they go straight to landfill. Generally speaking, you know, there are some reuse schemes in place, but really nobody's really looked at these figures in the past, and we've had to make a series of assumptions to come to this. So I won't dwell on that. Or, you know, within a report that we produced, there's much more details on this. So you've got the whole issue of, you know, waste sitting within the broader aspect of circular economy. And next slide, please. And this particular project sits with a number of projects we've been doing, looking at, for example, the use of vegan leather as a substitute for animal leather in cricket gear. We have another project where we are looking at reuse repair infrastructure in the UK. And another project where we're looking at the carbon associated with reuse of cricket gear. And another project that's going into more detail around the reuse side. So we're trying to sort of keep this sort of interaction and feedback going on between the different projects to build the knowledge. So next slide, please. So where we are to date in the project, so we're about 8-9 months in. We've had 3 meetings with the partners. We started off by looking to focus on 3 items of cricket gear in terms of thinking about circularity, but we've really honed that down to particularly focusing on cricket pads and gloves. We're in the sort of final stages of our thinking over developing a prototype that's more circular. In our other projects, we've developed some vegan leather inner wicket-keeping gloves, and also we've refurbished some cricket gloves using vegan leather. But that's a sort of one element of the overall picture of circularity. So we're trying to think through these issues and then work out the best way to get the prototypes developed. We produced a number of reports. We've done disassembly exercises. We've run an innovation workshop, and all the material is available and will be available from the website. What we've also done, and Darsh will talk about it later on today, is to do some more exploration over the materials used to produce cricket gear and some sort of thinking about perhaps other more sustainable options. So I think it's now over to you, Lillian, if my memory is right.
Yes. Thank you, Martin. Sure. So I'm going to present a brief summary of the findings related to the various tasks that have been conducted within the project. I will begin with the innovation workshop, followed by the disassembly exercise and the LCA, the streamlined LCA for the batting pads, before moving on to the sustainable materials for the gear. So we conducted an innovation workshop in December 2022, and the main objective of this workshop was to introduce circularity concepts to partners. Initially, an overview of product circularity concepts was provided. So we can see here the levels of circularity in the 10R strategies. This was followed by a 5-minute presentation of the findings related to a visit to Lord Taverners by our colleague Joanna, and as part of the reuse and repair project. Also, an online innovation session was planned in which participants were required to generate ideas related to product circularity for cricket gloves, pads and balls, followed by a 15-minute session to explore the 4 most feasible product circularity strategies specifically for a pair of batting pads using a predefined product circularity list. So in terms of the findings and discussions based on the visit to Lord Taverners, for those of you that may not be aware of Lord Taverners. Lord Taverners is a charitable organisation that provides innovative, inclusive and impactful cricket programmes for young people with disabilities and disadvantaged communities. And specifically, the sports recycling programme collects usable kit from across the UK through a network of local collection hubs and then redistributes either locally or overseas. So the main findings or discussion from this visit was related to the quality of the cricket gear that is donated, the health and safety issues regarding the reuse of personal protective equipment. It was seen as perhaps dumping waste on other people, but overall, if this gets people, more people playing the game, then it may be perhaps a plus. So some of the further challenges experienced by Lord Taverners relates to the limited infrastructure within the UK to support collection, storage, sorting and distribution of Second Life cricket gear, as well as some of the potential barriers to local reuse. So there are also legal challenges that are associated with placing an item on the market with used parts. And there is a need to ensure that, for example, retesting is cost effective for reuse, repair and refurbishment schemes to function. So certain products, for example, helmets cannot be reused for legal health and safety reasons. Now, this was provided to provide context for the overall workshop. After this, we conducted a think session. So during this think session, participants were asked to view 15 images to trigger ideas around the R strategies presented, and these were recorded on predefined wire board post-it notes. These were subsequently organized in terms of strategy, and primarily the main strategies that were considered for cricket gear were around reduce and reuse. However, at this moment, we didn't discuss the implementation of these strategies, as this was outside the scope of the workshop objectives, and then no concepts were developed for repurposing or upcycling. And then further issues that were identified from this exercise was the need for editorial to change perceptions around the materials used within cricket gear or the quantity of kit perceived as necessary. And then there was also further discussion around the requirement to foster sustainability within cricket and the need to create a supply chain for Second Life gear. Also, topics raised around women's cricket in particular. So can things be done, for example, within women's cricket? This is followed by the selection of the product circularity strategies. So as previously mentioned, participants were introduced to various circularity definitions. And then following on from the think session, participants were introduced with a generic eco-design checklist and were asked to assess which of the various design focus areas would be the most feasible for batting pads in specifically. So they were asked to score from 1 to 4, which they considered to be the most viable, where 1 was the least viable and 4 was the one that was perceived as having the most potential. So based on the discussions that emerged from the first half of the workshop and the product circularity strategy checklist exercise, participants identified the following strategies as being the most feasible for batting pads. And this was to reduce the process waste, maximize ease of maintenance, increase access to spare parts, increase the use of renewable materials. Within this section, we began to explore potential implementation of these strategies. So, for example, some of the ideas that started to emerge was to develop new solutions for washing, enable perhaps in terms of increasing the use of spare parts and maintenance. How could design innovations enable, for example, the removal of the inner protection, the pads that often have sweat stains, and then be able to wash, for example, the exterior case. So we can perhaps go through the questions at the end of the session. I will now move on to the findings from the disassembly exercise. We conducted the disassembly exercise on a pair of batting pads and a pair of batting gloves. However, it's pertinent to mention that the disassembly of the batting gloves was conducted as part of vegan leather project, but the findings are relevant to the circularity, to the circular cricket gear projects. So these were both products were disassembled manually using a seam ripper, and then components, the various components and parts were analysed to identify their function, technical and functional properties. So based on these findings, we developed the following bill of materials. So each material was weighed on a scale to develop a breakdown of various components. We added some of the technical requirements as well as the functional requirements. However, some of the materials are based on assumptions due to the lack of data, and also it wasn't possible to actually corroborate the materials with the manufacturers. This was subsequently used for conducting the streamlined LCA. So in terms of preliminary findings from the disassembly exercise, the size and the shape of the components, materials for the batting pads appear to be cut based on experience. So we believe that no layout plans have been used for cutting. And this was identified through the excess material within each component, so which is not required for the product's performance. The results also indicate that there's an increased waste of materials and resources, and the lack of standardization of internal components could potentially hinder the recovery and reuse of cricket batting pads. For the cricket batting gloves, the size and shape of components and materials appear to be cut using precise molds. No waste within the product was identified. Therefore, a recommended focus for product sustainability is on identifying alternatives to bovine leather used for the palm, and based on the material properties required for the batting glove, the palm appears to be the component that is most likely to deteriorate during use. So with this in mind, it is recommended to potentially focus on design features that enable, for example, the palm to be replaced. So following on from the disassembly exercise, we initially conducted a streamlined LCA for batting pads. However, there is a view to also conduct the streamlined LCA for the batting gloves. So the streamlined LCA was conducted using Sustainable Minds software. And this is the first attempt to assess the environmental impact of batting pads, as no LCAs were identified prior to this research. So it is also pertinent to mention that the LCA results are indicative of the environmental impact rather than definitive, and that several assumptions had to be made due to a lack of primary data. So the majority of the calculations have been based on secondary data and industry averages. The LCA, the streamlined LCA, addresses the entire life cycle of the product. So this includes the production with extraction of raw materials, processing, manufacturing, and assembly. transportation is included from the suppliers to the manufacturing site, however, and to the final user within the UK. However, from distribution within the UK has been excluded. In terms of use, transportation to the end user has been included as part of the use phase, and with end of life, the calculations assume that all materials, parts and components of the product have been landfilled, and therefore no transport data has been collected for end of life to waste and treatment plants. In terms of the goal and scope, the goal of the LCA was to generate insight into the environmental impact of cricket batting pads, to identify opportunities for improvement through circular design principles. The functional unit was calculated to be 3 seasons, which equates to 60 games and 30 indoor nets. However, this assumption was based on younger players, because going back to the results from the survey, the average of games played per year was 13. So just to clarify this point. In terms of system boundaries, we included, as previously mentioned, production, distribution, use and disposal. So packaging was excluded from the calculations. As for geography, the assessment is based on the sole use of the cricket batting pads being used within the UK. And then for assumptions, the origin of materials and supplies used for manufacturing have been calculated to be sourced from, for example, China, but as well as northern India. As well as mode of transportation. So assumptions have also been made in terms of the mode of transportation from the various suppliers to the manufacturing site, and from the manufacturing site to the UK. Again, going through the life cycle inventory, these are some of the assumptions that were made. So the extraction of raw materials have been transported from northern India to the UK. In terms of transportation, we have included various modes of transportation. So land vehicles from the suppliers to the manufacturers, and then oceanic freight from northern India to the UK. In terms of use calculations, internal calculations haven't been collected for this assessment. Now, moving on to some of the results. In terms of the environmental impact, the results indicated that the highest environmental impact associated with the production of a pair of batting pads is human toxicity, and this is associated with the production of the high-density foam used for the internal paddings. This was followed by global warming potential associated with the CO2 emissions embedded in the entire life cycle of the product, as well as fossil fuel depletion due to the extraction of due to the use of raw materials for the majority of the product's components. From a material perspective, the 3 main contributors to the product's total score are the use of high-density foam. This is followed by the polyester that is used for the product's lining, as well as a polyester used for the mesh within the cricket batting pads. Impact by life cycle stage, the main contributor is the product's carbon footprint. To the product's carbon footprint is the manufacturing phase. And this is primarily, within this phase, the main contributor is the production of polyester for the product's lining and mesh, and followed by the production of high density foam. Now, the third contributor to the carbon emissions of the product is related to transportation. However, caveat to this is that transportation calculations for this report were only considered for the primary materials to the manufacturing sites in northern India and the shipment to warehouses in the UK. So, Martin, would you like to add anything to this? Or oh, sorry. Oh,
nothing to add, please. Yeah.
okay, sure. So moving on to the conclusions, this offers an initial overview of the main areas of environmental concern related to the product's life cycle. Now we do have, we have planned for further, this is the baseline for the environmental impact. We have planned further LCAs to include, more data as this is collected, and also based on different scenarios from the implementation of product circularity strategies. The highest impact is related to the manufacturing stage, and the LCA also indicates that the use of polyester for the lining and mesh are the highest contributors to the product's overall carbon footprint. And this is despite only representing 220 grams of the total weight of the batting pads. And then the study also indicates that the use of high density foam represents the highest environmental impact in relation to human health damage due to its carcinogenic properties. And then a primary gap within the LCA is related to the CO2 emissions associated with the distribution of raw materials to suppliers, manufacturers, and warehouse, as well as the final distribution of the products to retailers and customers. So based on these findings, and in terms of recommendations for the implementation of product circularity principles within the batting pads, the focus would be to implement strategies that would extend the life of the product, so that the average use of the product can be extended beyond 3 years, or that parts and components can be replaced. Further to this, in terms of strategies to replace, reuse, and or extend the life of the high density foam used for the internal protective padding, as this appears to be the one that has the highest impact. And then thirdly, aligned to the replacement, reuse, and extending the life of specific materials and components. This is also relevant for the polyester that is used for textile lining and mesh, as this represents the primary contributors to the product's overall carbon footprint. And then finally, for this to be economically viable, there's a need to explore the potential cost implications of adapting the product to include these recommendations. So now I will, yes.
Maybe I just would add one key point. It's one of the challenges we've faced overall in the sector, and particularly looking at the cricket gear products, if you like, is lack of data overall on the market specifically. So there's a call out. If you are involved in cricket gear manufacturing, we are very interested in talking to you about your data. Anyway, I'll shut up and pass across to Darshil.
Yeah. I think, Martin, you put it very accurately. That's one of the biggest challenges, alongside lack of analysis. Even theoretically, or reverse engineering processes, for example, the one that Lillian and Martin have been using to actually understand how many components come together, and publicly discussing about this, I suppose, as well. So that's where some of our work that we are doing on alternative materials for cricket gear comes in as well. And just to put the caveat that completely recognizing that the biggest gains will be in redesigning some of these products, and looking at the things that Lillian was mentioning in the previous slides in relation to life extension of products, reuse, consideration of easier design for disassembly. So in the previous on Monday's presentation on vegan leather cricket gear, I think Prakash, who is on this call, mentioned that it takes, I think 1.5 gloves can be put together by one person in a day. And that, to my mind, is extraordinary. It shouldn't take that long, and it demonstrates the complexity of cricket products and therefore the challenges around deconstruction and considering what happens to their circularity. But we will particularly focus on alternative materials for the next several minutes. Lillian, if you could go to the next slide, please. Thank you. So one of the clear things, just to reiterate, is that many of these cricket gears, particularly the components we have looked at in terms of the cricket ball, gloves, pads, there are multi-component materials. Often these materials are derived, processed, assembled through very complex supply chains, so traveling across industries and across countries. And they're put together into very intricate assemblies, making the disassembly difficult, but also the assembly itself difficult. And also these are often designed without consideration for end-of-life disposal and disassembly. It's the classic thinking that has been taking place for the several past decades, where we have been taught as product designers about design for manufacture or design for performance, but not necessarily design for disassembly. And this sort of approach is particularly becoming important in terms of life cycle thinking. And the key challenges that I consider in terms of consideration of sustainable materials is this aspect of many of these materials are going to be new materials, and that often rings alarm bells to manufacturers because they are not completely certain about the materials specifications, how confident the players might be in terms of meeting exact materials. And sometimes that's to do with over-engineered products as well. A product may be significantly over-engineered, and you don't necessarily have to meet exactly the same properties as the current materials are meeting. Oops. Yeah. Sorry, that was a fire alarm test, so I didn't want to go to the previous slide, Lillian, sorry. Yes, so new materials. The second challenge is, how is sustainability demonstrated? Some of these new materials might have self-certified sustainability. It's often a loosely used term, and life cycle assessment is very critical to this. So even when we propose some of these alternatives, it may be that when you start scaling these up, when you consider the nitty-gritty of where the materials, the raw resources are coming from, that might demonstrate that it does not significantly improve the sustainability or on specific environmental indicators. And Lillian in her LCA was considering a range of different environmental impact indicators, and some of them range from the very commonly known indicators such as carbon footprint or embodied energy, but they can also include water use, eutrophication, land use. And because a number of these materials might be plant-based resources, land use becomes a bit of a challenge, especially when you start thinking about if these are coming from competing food crops, for instance. The other aspect to consider is scalability, and how much of these new materials are available, and therefore the supply chain considerations as well. But keeping these at the back of our mind, we look at some existing materials that are used and also potential alternatives to them. Next slide, please, Lillian. So this, I was trying to put together a visual illustration of the range of different materials that are currently used in cricket gear. And this sort of chart is referred to as an Ashby chart. It's a materials selection chart, where you can have on the two axes different material properties, and they can be things like the hardness of a material, the stiffness or the strength of a material. They can also include environmental impact indicators. So currently on the x-axis, we have carbon footprint of primary production of the typical grade of the material for a unit volume of the material. I used unit volume rather than unit mass for specific reasons. But it demonstrates the range of different materials that are used, what their range of properties are, and therefore what exactly we need to be substituting, providing an alternative to. In this case, for example, if I just pick out an example, what we can see is on the top right-hand corner, we have natural fibers, for example, and flax, linen is used as a stitching thread in the seam of cricket balls, and wool towards the right-hand side is used sometimes for wrapping the core, the cork rubber core in cricket balls as well. And you can see the range in carbon footprint of these two materials, for instance. And that's quite interesting, primarily because wool comes from an animal-derived product, and therefore there are implications to how you value or take account for carbon footprint of sheep. Yeah, that sort of industry as well. But by and large, one of the interesting things we find is that you generally have two extremes. And the fascinating thing is that a lot of the materials used in cricket ball are already natural materials. So leather, flax, wool, cotton sometimes, willow for the blade, for instance, as well. And these have 100% renewable content. In contrast, particularly since the 1940s, with the advent of polymeric materials, a significant amount of elastomeric plastic materials derived from fossil fuels have become regularly used. And this ranges from the foams that Lillian was mentioning, the polyester linings, the rubber that is used in the core of the materials sometimes, as well as some other products. There are only a couple of exceptions. So the cardboard that can be used in the knee covering of the pads, or a rubber, which can be derived from natural rubber trees, and then semi-synthetically processed to harden it, for example. But you have this binary of either natural or completely synthetic, which I found particularly interesting. They're also very lightweight materials. So all of these materials would be classified as polymers or composites in material science. So lightweighting quite clearly is particularly important, and that's understandable as well. And in the form of the material is also important, because when we were thinking about substitutes, we need to make sure that any new materials can also be produced in these different types of forms. So particularly they are often foams or fibers in textiles. Sometimes they are sheets, so in the form of leather casings, for example. Very rarely they are bulk materials, so the blades of the cricket bats or the cores of cricket balls, for example. Generally, they are foams, fibers, textiles, sheets. Next slide, please, Lillian. So if we look at the cricket ball, there are generally 4 different enveloping materials, main layers. You have a coating, a lacquer or polish. You have a stitched casing with a seam. And then you have possibly either just a central core, or you have a central core alongside a midsole core. And this is quite interesting in terms of who is manufacturing the cricket balls. So the big 3 players, Kookaburra, SG, and the Dukes, they have slightly different or very different designs. And then there are also other players who produce different types of cricket balls, which lie within these morphologies. So typically, the outer surface will be, so in this slide, one of the things that I also wanted to mention was where the materials are coming from. So for example, nitrocellulose lacquer, polyurethane coating, or shellac wax might be produced in India or some other parts of the world where particularly these polymeric materials are readily available at lower costs. The bovine alum tan leather casing might be from UK or India. The linen is probably going to be from France, because France provides 80% of the world's high quality linen fabrics or fibers. Cotton might be from India for cost reasons. For the stitching thread, it could be nylon as well. Wool might be from UK, New Zealand, possibly from certain parts of India or Pakistan as well, to wrap the core. And the cork is most likely and usually from Portugal. If there is rubber that is used, and this is increasingly becoming common, it is from Malaysia, Thailand, or India, because they are the biggest rubber producers. Just like the cane usually comes from Malaysia as well. Interestingly, if you look at the history of cricket balls, it used to be a square cork in the middle, which would be wrapped by layers of cork and wool, worsted yarn, and usually woven tightly, spun tightly, and then it would be wrapped again by this leather casing at the end. But particularly over the past decades, rubber is very, very common. And we'll get to that in the next slide, please, Lillian. So if we look at the various layers again, for the coating, and we've done this analysis in terms of trying to think about the functional requirements of each of the layers. So for the coating, for example, the protection of the leather is quite critical. Without this, the leather would not perform as it does. It's very important to remember this, that the coating is as important as the leather itself, particularly for wear and moisture-related degradation. It also provides the glossy appearance and the maintenance of the shine, which is quite critical for sewing, for instance. The compatibility with leather is quite critical. And increasingly, particularly, for instance, for kookaburra, for example, which is where they used more of a mechanized process, the sprayability of lacquers can be important. And that is why rather than applying these manually, they are just sprayed, including polyurethane coatings or nitrocellulose coatings. And that particularly gives a more uniform application of the material, for instance. So a range of different current materials are used, including in the early stages of the leather preparation, and then for final finishing as well. So it could be aniline, synthetic buck fat coating, and then either nitrocellulose lacquer is used. And this is all of these, or nitrocellulose and polyurethane coatings are vegan materials, if that is relevant or important. Nitrocellulose is mostly plant derived. It comes from cotton or wood, and then it's mixed with acids to produce this sort of lacquery material. Alternatively, polyurethane coatings are very common. Polyurethane coatings are also very common in leather textiles and textiles in upholstery generally across the fashion sector. If you go into the automotive industry, for instance, where you have seats that are being produced or other products, these would be coated with polyurethane, particularly for moisture resistance, for instance. So there are lessons to be learned from other industries. I think that's what I'm trying to allude to. There's also historically shellac wax that is used, but I'm not sure if it's used in large quantities today anymore anyways. In terms of alternatives, a number of industries have moved towards other PFC, so pentafluorocarbon free materials that are durable and water resistant, DWRs as they refer to them as. So PTFE, Teflon coatings, are not uncommon, and materials such as Bananatex, which we have looked at as vegan leathers, they commonly use these for high durability applications. Beeswax is still commonly used, so that could be considered, and there is variable responses in terms of how the material performs, particularly over longer durations. A new innovation that has come through is funky supercoating. This is based on fungi that are derived and then applied onto leathers. But again, this is very much at a proof of concept stage. So we'll see where this sort of this sort of product goes. I think an area we should look at more closely, and it's growing rapidly at an industrial scale, is biopolyurethane coatings. So rather than polyurethanes, these are derived from bio-based resources, typically plant-based resources, and companies like Bayer, or formerly Bayer, they have spun off into Covestro in Germany, wider in Europe as well. And they are actually running quite interesting circular foam projects across Europe as well, because they not only look at upholstery, high quality leather applications or polyurethane applications, but also in the construction sector in both rigid and flexible foam applications as well. In this case, one of the things to mention is that currently BPUs can be drop-in alternatives, which is always an advantage, but they are a very small percentage of the current market. So only 0.001% of the polyurethane market currently are biopolyurethane. It's still in the order of thousands of tons, but it's still much smaller than the amount of polyurethanes we use. And they're using a range of different precursors, which is interesting. In some cases, they're using industrial sugar and then chemically processing this to make aniline. So if you remember, aniline was used or is used sometimes for treating leathers. And then they're catalyzing this composition with microorganisms. And some of the raw sugars come from corn, from straw, from wood. They're also using waste vegetables, particularly those that are not coming from human consumption. They're also looking at waste or residual oils, so recycled vegetable oils, for example, from the food industry, or fats from the food industry as well. They're producing chemicals like biosuccinic acid. These are used to produce leathers in some alternative leathers. But more importantly for polyurethanes, they can be used to produce the polyols or the diols. So at least 50% of the polyurethane is going to be bio-based, but they can reach up to 70% bio-based. And I think they are confident that this can reach 100% bio contents. Lillian mentioned that there are some carcinogenic possibilities of polyurethanes, and that usually comes from the isocyanate component. So it's a two-component reaction, and the isocyanate particularly can lead to human toxicity related challenges, and increasingly REACH compliance is becoming difficult. And over the next decade or so, I'm pretty confident EU regulations particularly, I'm not sure if others might follow or not, but EU regulations might make isocyanate use more and more complicated and tricky. So that's something to bear in mind for flexibility in the industry anyways. In the next slide, I'll try and move quickly now. We looked at the casing, and in the previous presentation on Monday, we talked about some vegan leather alternatives. We have identified over 123 from a range of different resources, mostly bio-based. So they can come from fungus, from the trunk or stems of plants, from fruits or waste industries as well. So grape skin, potato starches, apple skins, coconut fibers, things of those sorts, as well as from leaves and fish waste as well. An important aspect to remember is many have a sizable non-renewable component still, so they can be 30, sometimes even 70% still polyurethane or some other fossil fuel derived material. And this is primarily used to improve durability. So for coatings, particularly water repellents. Some of them also use finishing just as a top coating to improve durability as well. And often this is fossil fuel derived. They're also often currently limited in scale, and they're targeting non-performance sectors, so the fashion sector, particularly because that's where innovation drive is and investment is easy to come by. As we have found, partnering with the sporting sector can be a bit challenging, particularly the cricket gear sector. In the next slide, we have, as part of the cricket gear project, gone on to extend the research that we started off in the vegan leather cricket gear project, particularly doing non-traditional testing. Beth, in particular, spent a lot of time trying to do abrasion testing of many of these leathers. So we tested BananaTex, so derived from banana leaf fibers, abaca fibers, BarkTex from tree bark fibers, Hide Biotech from fish waste leathers, as well as Pinatex pineapple leaf fibers, and also comparing these to the glove leathers and ball leathers used conventionally in cricket gear, provided kindly by Gun and More to us. Interestingly, we found that the leather used for the casings of cricket gear, bovine leather, is significantly stronger than any of these leathers we have tested. But that's primarily because of the thickness that it comes in. Many of the conventionally available or newly available alternatives do not come in the 3.5 millimeter, 4 millimeter thicknesses that are required. The other aspect we found quite positive was actually many of these alternative leathers can provide water repellents to the same level as bovine leathers. So we are getting contact angles, hydrophobicity as good as, or sometimes even better than bovine leathers. And abrasion behavior is also pretty good in many of these materials. So we looked at how much material is lost as a function of time if the ball was rolling on the ground, for instance, but replicating it through different means. And we found that if you compared bovine leathers that are used in cricket gear or the palms of cricket gloves, that was comparable to some of these alternative leathers, except for BarkTex for various reasons. We can go into those details later on. In terms of the core, the cork is often has been already replaced by rubber or cork rubber wrap alternatives, in which both the cork is ground and the rubber is ground, and these are molded exactly to shape so that the leather can be wrapped around it, or the twine can be wrapped around it. Some of the alternatives that might be interesting to explore, because the cork is already granulated, it might be worth using waste cork. And there are already companies like Recork in the UK, but also across the world, that are using these sorts of end-of-life wine bottle corks, for example, but also waste from that sort of industry that could be used in granulation. Waste also from the construction industry, because the construction industry does use cork, particularly for tiles, for example, for insulation sometimes. You might have seen that the sterling price in the UK in 2019 went to the cork house, where they used cork as the external and interior material of the building. And because of that sector growing, we need to think carefully about cascading uses of our precious bioresources. So how we can use resources from the construction sector, if cork is an example, for cricket gear, that could be quite interesting. And also look at various mixes, and I'm sure cricket industries are already looking at that. That's why they have these formulations. If you look at a tennis ball, a lot of it is already just rubber, so that gives you the more bouncier feel to a cricket ball, and addition of cork might change that performance slightly. Alternatives might also be agricultural waste, because it's granulated, woody barks, alternative to cork, such as from hemp sheaves, or rice husks, or even coconut palm wood. So coconut timbers might be very useful for this sort of applications, as well as balsa, which is already used as a core material in various applications. For seam materials as alternatives to linen, linen is already a good environmentally friendly material in terms of its sustainability profile, and it should be used in preference to cotton or nylon. But in case you want further alternatives, hemp, jute, rami, sisal, these are also very good stitching threads, which have historical precedence in high quality, durable applications, even, for example, in the shipping industry and in the sailing industry. So where the material is in close contact to water and constantly abraded with different surfaces. So that's something to explore as well. For the midsole core, wool needs further alternatives, and we definitely need to consider that. Not necessarily replacing wool for a different material, but even just considering recycled wool from the carpet industry, for instance. So I've spoken to a number of different experts. One of the challenges is that currently worsted wool yarn is used, and worsting is a very interesting textile technology that was developed in England a long time ago, particularly in that sort of region, where you're using long wool fibers, usually about 50 millimeters in length, to produce this sort of wrapping fiber that is usually thicker in its dimension, and therefore that length is quite critical. But recycled wool fibers of that sort of length should be completely fine. Alternatively, cashmere or rayon, viscose, which is derived from wood waste or bamboo waste fibers, can also be used for these sorts of applications. And again, I've spoken to the textile experts for this. Or cationic polyester and nylon would be better than wool in terms of its environmental impact if recycled wool cannot be used. The other opportunity is also to look at blending of wool with polyester or nylon, in which case you need to consider the lengths of the fibers that are used. So there are some technical details that you might have to consider. One of the things you cannot do is blend wool with other short natural fibers like cotton or something of that sort. So there are some limitations to this as well. In the next slide, I think we'll quickly run through gloves and pads. I've devised, because there are similar materials in gloves and pads, I've tried to just group them together. It's easier to communicate it that way. So there are materials I qualify as high impact resistant, rigid, molded components. And these are the materials Lillian was mentioning. They are cut to shape, they are formed to shape, they're often molded. And this include, for instance, the polystyrene kneecaps and pads, as well as the polypropylene finger and thumb inserts in the gloves. In many cases, the alternatives would be to look at semi-synthetic biopolymers. So PLA is an example, which is derived from sugarcane or beetroot sugars. And you can easily 3D print or mold them, injection mold them, same processes that are currently used for these sorts of application, and you can get the same sort of impact resistance quite easily. You can also use sugar-based or starch-based thermoplastics, and there are lots of different examples from these derived from potato starch, cassava starch, or sugar starches as well. There are also seed oil-based plastics, so cashew nut seed oils, soybean seed oils, castor oils, rapeseed oils as well, depending on which country you're in. So if you're in the US, soybean castor oil might be more interesting. If you're in the UK, rapeseed oil is much more commonly available, and it's actually, I think 70%, last statistic I heard was 70% of the rapeseed we actually produce goes into cattle feed or other sorts of animal feed anyway. So consideration of how we are diverting some of our resources can be looked into. The other alternatives are short fiber biocomposites, and recently Martin, Lillian, and I spoke to some colleagues in Pakistan that were looking at flax reinforced composites for some of these cricketing applications as well. So you can use flax, hemp, jute, and even secondary waste fibers, date palm fibers, fibers that are from coconut or rice husks, from secondary resources, from other primary resource, or other waste fibers from the textile industry, so carpet wool, denim cotton, polyesters. I'm sure a lot of you know that the polyester industry is moving into bottle to fabric recycling, for example. So beverage bottles are being produced into clothing. And usually it cannot go the other way. So if we are using recycled plastics, that would be much better as well, that rather than virgin plastics. Alternatives also include using furfuryl alcohol, so sugar waste derived resins. In terms of high impact resistant rigid components, so these are not necessarily molded, but would be things like canes and paper boards. These are already pretty good materials, but you could look at, again, waste or short timbers. You don't necessarily have to use canes. Shipping from Malaysia, for instance, you can use waste timbers that are coming from the construction sector. You can look at recycled cardboards as well. So in terms of short timbers, one of the challenges in the UK, if you're looking at the UK supply chain, is that 80 to 90% of the hardwood we produce goes to bioenergy, to Drax power stations. 60 to 70% of the softwood we produce goes for pallet making and fence making rather than the housing construction sector as well. So we need to think about cascading use of resources, which is an important part of circularity thinking anyways. And then also other waste plastic materials. Why can't we use PVC piping, make it into strips and use that as the interior for that? So that's easily possible as well. I know there are going to be some challenges to get particular specifications right, but given the specifications that are used to make some of these components already, this shouldn't be extremely challenging considering how much variability there is in natural materials anyways. In the next slide, I think this is the final main slide, looking at gloves and pads. For cushioning, foam and filling, in terms of alternatives for PU foam and the cotton polyester blend wadding, non-isocyanate polyurethanes, that's particularly important. Bio-PUs, I mentioned Bayer, Covestro, but there are at least 9 or 10 big players that are looking at bio-based polyurethanes using a variety of natural oil or natural carbohydrate feedstocks from soybean oil, sugar-based, cashew nut seed oil, castor oil, and I can give a whole list that is already in the report. Some of these are going in the automotive sector, some of these are going in the mattress making sector, upholstery sector, some of these are going in more high performance sector in construction as well. And we can also look at waste fibers for wadding, for instance. You don't have to use virgin cotton and polyester to make the wadding just as a filling material. This can be any waste material, to be fair. The lining and skins, again, leather and breathable polyester meshes. Lots of different recycled polyesters can be used, semi-synthetics like viscoses or natural fibers, PVA, chamois leathers, viscose base that we are looking at as well, and other alternative leathers as well. I think that's primarily it, and we can look at the conclusions, I think, in a discussion. I think it's better to talk about it in a bit more detail. Thank you.
Thank you, Darshil. Yeah, so just I'm aware of time. I will quickly run through the findings on the online cricket survey. So yes, following up on the findings presented throughout this webinar, the next natural step was to conduct an online survey to understand users, players' perception on sustainability issues, but also identify key product failures to assess the potential for reuse, repair and refurbishment of cricket gear. So a brief reminder of the survey for those that weren't here on Monday. The survey was conducted in April of this year, and it was circulated to an email list of 114 individuals involved in cricket, 5 cricket players, and also distributed amongst social media. Overall, the survey received 42 responses. And then in terms of the demographic and context, the following is a percentage breakdown for the level of play. 83% of respondents were identified as male players, and the age range was primarily over 55. The number of games played per year was 13, and cricket gear use phase appeared to be kept 8 seasons by 38% of respondents, and between 2 and 3 seasons by 36%. In terms of sustainability considerations, 57% of respondents have considered or indicated that they have considered the environmental impact of cricket gear in the past 6 months. However, when asked to elaborate further, most respondents had not identified specific environmental issues. For those that had considered environmental considerations, most focused primarily on the disposal of cricket gear at the end of life and the carbon footprint associated with the cricket gear supply chain. Now, with regards to repair, reuse and refurbishment of cricket gear, 59.5% indicated that they were unaware of any organisation or programme dedicated to these services. And for those that indicated to be aware of organisations and programmes focused on repair, reuse and refurbishment, the most widely mentioned organisation was Lord Taverner's kit recycling scheme, followed by local club initiatives. We also asked participants to indicate the reasons for purchasing new gear, and this was to understand if this was associated with product failures or a change in trends and other considerations. So the main reasons provided were primarily related to wear and tear or general use of the equipment. So, for example, becoming too worn out for use, broken, damaged, or unusable due to other general use issues, such as being unable to remove the stains, wash their cricket gear, and also the cricket gear losing odor considerations that were also mentioned during the repair exercise on Monday. Secondly, participants indicated that performance or new technology considerations were a reason for purchasing new gear. So, for example, seeking improvements in performance, or if technology or design innovations had been developed in more recently. And then thirdly, the reason was that due to sponsorship changes, so perhaps changes in the logos or the color and so on. Now, in terms of identification of product failures, the main failures identified for the survey, we only asked participants to indicate failures related to batting pads and batting gloves. So we excluded for example, balls and other clothing. So for batting pads, the main failures were related to the straps. So, for example, these tearing off or breaking, becoming quite loose, and the Velcro straps failing. Other issues related to the batting pads were the outer material. So the PU leather, for example, it rips quite easily. It splits and sometimes causes the internal padding to become exposed, and occasionally to start to fall out from the product. And then further padding related issues were exposed padding and the mold due to sweat and storage conditions. So generally, we'll go into this further, but generally, it tends to be stored into a bag after the game, and then stored in the garage until the next time it's played, so never allowing for the products to dry properly. Now, the main failures identified for batting gloves is related to the wear and tear of the palm. So this includes stiffening and cracking of the leather, and which impacts on the grip of the bat primarily. And then also, holes within the thumb and the palm, as we saw on Monday with regards to the refurbishment exercise. And then also within the gloves, the straps were reported as being an issue, so either breaking or the deterioration of the Velcro. And then, as mentioned again in the previous webinar, sweat and odor considerations are a main contributor to the gloves deteriorating. So, for example, appearance and the touch of the glove, as well as the smell of the gloves after use. So with this in mind, we asked participants how they cared for their cricket gear and the market acceptability for repair services. When asked these questions, most respondents indicated that they do not provide specific care for their gear after each game. So apart from wiping them down after the dirt and the mud every now and then particularly on hot days, the gear might be set out to dry in the sun, but otherwise it's just stored in a bag until the next game. In terms of disposal of cricket gear, 29% indicated that they donate unwanted gear to charity, while 26% donate it to the club bag. Followed by 19% indicated to store unwanted gear in an attic or garage. And then regarding the acceptance towards the use of a repair service, 86% of respondents responded that they would be inclined to use the service if made available. And the main reasons provided were that this would potentially reduce the waste, but also cost savings was mentioned as a reason to use these repair services. So if this was cheaper than buying new gear, then yes, they would be inclined to use the repair services. And then thirdly, to reduce the environmental impact associated with the production of new gear. So and then lastly, respondents were asked to indicate in their own words what they thought would enable the establishment of repair services for cricket gear. And the findings suggest that there's perceived to be a lack of repair services available. So within this to include access to the infrastructure. So for example, places to take the gear and the implementation of specific systems such as collection points and to facilitate transportation of the gear to be repaired, and also collection services. And then secondly, it was identified that there's a need for an increased awareness of repair and donation services. And thirdly, it was identified that there is perhaps a need for design innovations that can facilitate repair and refurbishment in the first place. These are some of the main findings from this survey. And now I will pass the slides to Martin
Okay, I think for time, I mean, you can read this, and we'll circulate the recording. I mean, one thing I just quickly mentioned is that we recognise that perhaps our survey was slightly biased towards older playing, players. It wasn't the core group, but in a sense that was some of the findings were in one level even more interesting, particularly the interest in the potential use of vegan leathers, because you wouldn't naturally associate older generations with being so interested in potentially vegan leathers, maybe a bit more conservative, but also I think it was sort of quite interesting that the interest in the repair services. So I think we've got a pretty hard stop at 11:30, unfortunately, today. So I think maybe if anybody has any questions, maybe we can sort of tackle them. So over to you guys. Do you have any questions? And all the information reports will be available.
I have a question, Martin, if I can.
Sure, go ahead.
I think there are, excuse me, I think there are a lot of challenges in environmentally friendly materials and new designs, and 2 or 3 particular ones. Number one, PPE, it has to conform to PPE. Number 2, connected with that, it has to give adequate protection. And number 3, people like lightweight stuff. So if our new materials are heavier, I'm not sure how we'll tackle that. So I think it's quite an uphill task, but still it has to be done. So hats off to you guys for trying. And my second point is, I've noticed at least twice that you've mentioned that you're not getting cooperation from the industry. And I presume that's because industry doesn't want to share some of their secrets, I guess. So I would suggest someone should fly out to India. These days, there's a direct flight from London to Amritsar. I've used it many times. Takes 8 hours. From Amritsar to this hub of sports goods manufacturing in India is a 2-hour drive maximum. And you can bring a bag of alternative materials, sit down with a manufacturer. I think that would, you could also see about picking stuff to pieces and see what happens.
I mean, I think that's brilliant, and we'd like to talk to you more about that, because we're planning to put in a proposal to carry on the work, and that would enable us to put a budget in to do exactly what you're thinking about. So before I pass over to Darshan and Lillian, just a couple of quick comments. It is, I guess, like any new innovation, both new product or redesign, we have to operate within the constraints of regulations, PPE, cost, etc. I think a little bit on the lightweighting. I think already, as Darshan, I think, have identified, a lot of the materials are quite lightweighted already. I think there is an issue we have already started to tease out, around the PPE requirements. There is, the regulations are there, but there's still a lot of uncertainty in the sector. There's a lack of testing capacity for first life products, but also what has been fed back to me by the British Safety Federation, who are involved as a trade association, is if a product was placed back on the market, refurbished, etc., second life product, let's call it, they would say was strictly within the law, it would need to be retested. Now, one of the things we have started to sort of think about is if there was a more simple test there, you know, because a lot of the pads, for example, in terms of the main PPE requirements, aren't going to lose their functionality. They're not going to really lose the ability to crack a shin bone, you know, and most people aren't facing enough, you know, the elite level where it will go through the pad in that sense. So I think there are still many issues, you know, associated with the PPE, but yes, we are incredibly aware of that. So maybe I'll just quickly pass across to Darshil.
But can I just ask a question? I'm sitting here diligently listening, and there's a lot of interesting stuff on the materials. I didn't hear much about the economics of this, and consequently, what is the scale of the problem? I mean, and also, had you looked at this in terms of the difference in life cycle assessment between playing cricket at the highest level, where there must be a much higher churn of equipment, compared with the vast bulk of people who are playing at a sort of recreational level?
We've considered, you know, a lot of those issues, and absolutely. I mean, cost is a main issue. That's why that's why it's gone out to India. You know, there's still labor intensive in many of the aspects, as we said. You know, part of the challenge, if we are to bring stuff back to the UK, is exactly that. So the sector really exists in India. You know, how you could make it economically feasible to do something in the UK is a big question, or any other market. In terms of life cycle assessments, they don't exist on cricket gear, so we're into new territory. And I think going back to the issues over that Prakash mentioned around confidentiality, is yes, we've asked the guys to sign confidentiality agreements, but they deem it to be too commercially sensitive even to sign confidentiality agreements. But of course, we did our disassembly exercises, and we could find out the components, materials, etc., etc. So there's still many issues around this, and John, sorry for time, we're not going to be able to tackle in detail your questions, but if you want to follow up, we will follow up in a bit more detail. You were just on a time pressure today, unfortunately. Yes, we have looked at it. As Darshil played high level cricket, I played high level league cricket, so we're aware of the issues from a player's point of view. But it really is a sector where there are many unknowns, a lack, let's say, a lack of sustainability and circularity as a driver for an innovation has not really been thought about. And there are these PPE changes hanging over the sector, which are unclear, that perhaps will impact on new British standards that exist, but that whole revision of the British standards has been stalled until the industry sorts itself out with the regulators, in that sense, Trading Standards Authority in the UK. As to where they are. So I'm sorry, guys, we just do have this hard stop today, unfortunately. So I'd like to thank everybody for their questions and focus, and thanks very much on Lillian and Darshil for their presentations. We may well run this again, and we may well do a summary, I think, of this for a wider audience, because we've tried to target this at the sector. We've built up quite good, lists in the sector, but, we're finding it difficult to engage. So very open to ideas of further engagement, and Prakash, we will be definitely coming back to you if you're open to that. Yeah. Okay.
I'm retired, actually, but I'll
Well,
talk to my son.
okay. Well, thank you all. Thanks very much for your engagement, and see you at an event in the future. We're going to be actually, Lillian, just to move on to the next slide, perhaps the final slide, just very, very briefly. We're actually going to run a third webinar. Actually, this is some other work we've been doing where we were going to analyze the repair, reuse and refurbishment infrastructure in the UK, and analysing particularly what organisations that Lord's Taverners have been doing in terms of their reuse schemes as well. So that will be coming up later in the month. So thank you all for your attention, and sorry we have to have a hard deadline on this, but please follow up if you have any more questions or observations. So thanks again. Thanks very much. Yeah. Cheers.
Sure.
Bye.
Thank
Bye.
you. Bye.